Java Lambda expressions play a prominent role in Java Stream API, and I encourage you to watch these videos by Jacob Jenkov and Cody Simpson. And here in this video I'll just show you a very short example of a list of numbers and a Lambda expression that simply prints the value of the list element and adds a space. So here it goes, something like this. Let's fix the imports for the list and arrays classes, and we'll try running them again. Let's save it and test it. You can see that the numbers 10, 20, and 30 are printed. For each element inside of our list, of course, the elements are integers. Each integer becomes an input parameter to this Lambda function that simply takes the value, converts it to a string, and prints it together with a space. And I wanted to show you this sample because Java String library is very popular and typically makes a pretty heavy use of Lambda expressions. You probably have already noticed the difference. In our first example, we're just using very simple expression to generate the return value. But in our latest example for these integer numbers, what we do is that we take the input parameter and we use a statement block like this to define our Lambda function that prints values on the screen. There is a lot of flexibility how the code can create and capture the Lambda expressions. For example, in addition to our first version of the square capture here, what we can do is we can try examples like these as well. Let's just resize the screen. The first variety is how the input parameter is specified. Well, in our original example, we just had parentheses and the name of the variable x. The second version here uses explicit type name for x, which is a double. All right, and when there is only a single input parameter to our Lambda function, then parentheses become optional. You can just use the name of the parameter without the parentheses. And as I mentioned, the actual function is defined either by very simple expression, or you can have a block statement. And if the prototype of our computation requires a return type, then we must use the return statement inside the block statement to generate the return value. So I recommend that you try a few of these examples on your own to experiment with the syntax. And there are multiple examples of Lambda expression code in our book chapter 4.5. Capturing Lambda expressions like this is rarely helpful. Primarily, Lambda expressions are passed as parameters to a method, like our example right here with for each method. And we can also add our own generic method, for instance, like evaluate function, which I will add here next to our functional interface. Okay, I guess I need to resize this a little bit. Okay, so here's the evaluate function. So it takes the function as a parameter and the parameter to pass to this function. For example, right after we generate our square reference, then we can try to call this function, evaluate function, and pass square as a parameter, as a function, and the specific value as a parameter. Now this is a generic method because it's parameterized by type name. So this is a syntax in Java that shows you how to create a method which is parameterized by some type name. And then we start using this type name as if it was the actual class name as permitted by Java generics syntax. So anyways, we have our function, which of course is of type this interface I function. And then we know that this function has a method named compute. So when we invoke this method compute, we pass the parameter which is passed as an input right here, and this is the definition of our computation, x multiplied by x. So this returns the same result type. We capture the result and then we return the result from here. We can try something distinct like 3.5 just to make it different compared to other results that we print in the sample. So just to run it as is, you can see that it prints 12.25 as a result of 3.5 squared. And you may be wondering what is different between this approach and the original approach, where we just called compute directly. Once we captured our lambda function, then we were able to do the computations by referring to this method. But this time what's different is that now I can pass other functions to this method. For example, I can try something like this. I use this brand new Lambda expression based on the input, which is required by our definition of compute, and which is also using this block statement to define what this lambda function is supposed to do. And you can see that I'm just simply printing the argument. I return a blank from here because the return is required, and I pass a string as a parameter which says hello. So let's try this example. Just save and run it. Okay, so now we print hello. So what is computed at this stage when evaluate function is invoked is defined the first time by this expression and the second time by this block statement. And what's even more amazing is that the inputs, the data types that we pass as the input parameter x and the string right here are of course very different. In the first place we use 3.5, which is a double value. In the second place we pass hello, which is a string. Just remember that lambda expression should always have the same number of parameters and the same return type as the method in the functional interface, like compute method in generic iFunction interface in our example.